This is ACT Manual Section 6. ACT Manual Section 6, Averages, Medians, and Modes. This starts on page 43 of the ACT Manual. So in Section 6, as I said, we're dealing with averages, medians, and modes. These concepts don't tend to show up all that often on the ACT, especially medians and modes. Averages, you'll see a question or two on every test dealing with averages. So let's first talk about averages. First things first, in terms of terminology, you have to understand that these terms, average, mean, and arithmetic mean, they all mean the same thing. So if you see any one of those three terms on the test, you're dealing with what you probably know as the average, where you add up a bunch of things and divide by the number of things, and that's how you get your average. In terms of the average or mean formula, again, remember average and mean mean the same thing. Remember that what you do is you add everything together to get I'm going to go ahead and write down total / sum over the number of things. And all of you should remember that. It's pretty basic information. So your formula in terms of just letters would be average equals total over number of things, total being the sum of the numbers. So this little formula here is going to become important in a moment in our next section, so you might want to jot that down. Now in number 2, this would be an example of the most basic type of average question that the ACT could possibly ask. If you want to do it on your own, go ahead and do so. I'm going to jump into it right now. Monthly fees for single rooms at 5 colleges are these numbers respectively. What is the mean of these monthly fees? So I'm going to go ahead and circle mean because that's what they are asking. So what is the mean of these monthly fees? Well, we would just go ahead and I'm going to actually write this down. I'm not just going to do it in the calculator. I want a record of it on paper. So 370 plus 310 plus 380 plus 340 plus, let me get this guy out of the way, plus another 310, and we divide by 5, and that will give us our average. So our average is going to equal, I'm going to go ahead and do this in the calculator, turn this on. So 370 plus 310, plus 310 plus 380 plus 340 plus another 310. I'm going to hit enter so I get my sum or my total first, because remember, if I were to have divided by 5 at the end, the calculator would think I wanted to add these 4 numbers and then add 310 divided by 5. So be careful of that careless mistake. So I'm going to divide that by 5, and I'm going to get my average is 342. Let's make sure that is indeed what they were asking. Yes, it is. They were asking for the mean, and I'm done. So again, that would be an example of a very basic average question. Next, like I said, we're going to talk about this formula and a little bit of a rearrangement of it. So the more challenging average questions on the test will, as I said, not be like the one we just did. That one was very basic and very simple and very straightforward, and looked a lot like the average questions that you did when you first learned averages. On the ACT, what will happen frequently is a question will actually give you the average. It will give you the average, and it'll give you a number of things. Now remember, from the formula, from that, I'm going to go back up here and I'm going to look at this formula right here, A equals T over N. Well, that's the regular old formula, but if I'm given this number and this number, then my unknown is the T. And how would I solve for the T? How would I solve for that unknown? Remember, solving for unknowns is pretty much what you always want to do in any algebraic situation. Well, the way that I would solve for that unknown is I would multiply both sides by my n. So these n's will cancel, and what I will be left with is a times n equals t. And so what this does for me is it makes things slightly more efficient. If I'm given my average and I'm given my number, what I know is that I'm going to have to multiply those two things together to get the unknown piece, to get the total or the sum. So the average and the number will be given, and then the total will be the unknown piece, and in order to produce that total, I simply find the product of the average and the number of things, and that will give me my total or sum. And it is this piece of information that will likely be key to solving the tougher average question. So let's take a look at example 1a, just the bolded portion here. If you'd like to do it on your own, press pause. So this says the average arithmetic mean, remember those things mean the same thing, the average weight in pounds of 4 rocks is 27. Well, let's identify what we have here. We have a 27, which is the average. They say the average is 27. And then we have this 4, which is a number of things. Well, that's what I just mentioned, that the trickier average questions will give you an average and a number of things, and you will need to produce the total. So I'm just going to go ahead and I would actually, the day of the test, I would be writing down a times n equals t, sort of in this maybe like almost like a column format, where I have a in the first column, n in the second, and t in the third. I've got a multiplication and an equal sign here. So my average is 27, my number of things is 4, and my total would be, I would go ahead and do that in the calculator, but my total is going to be 108. So 27 times 4 is 108. Now it's important to pause and think about what this 108 means. Yes, it is a total or a sum, but more specifically and more usefully, it is good to know that this 108 would be the total weight of all 4 of these rocks added up. So if I put these 4 rocks onto a scale, that scale would read 108. Now, keep in mind, I don't know what any of these individual rocks weighs. It could be that one of the rocks weighs 107 pounds and the other 3 weigh 1/3 of a pound. It could be that they all weigh the equal weight. They all weigh equally, so 108 divided by 4. But the bottom line is I just know the total weight of all of them. Now, what a question might do is in the next phrase, so in example 1b, the second bolded portion, the question might then tell you something about one of the individual rocks. And indeed, that's what's happening here. They're saying if a rock weighing 30 pounds is removed, what is the total weight in pounds of 3 remaining rocks? So total weight, 3 remaining rocks. Well, remember, if we just produced the total weight of all 4 rocks, and we said that was 108, and we take away a rock weighing 30 pounds, well, now I can use this 108 and this 30, and I can just subtract the 30 out of the 108, and I get 78. So 78 would be the weight of the other 3 remaining rocks. Again, these questions are going to tend to hinge upon that total that you produce by multiplying the average and the number of things. Page 44. Let's go ahead and take a look at a couple of examples dealing with ant. If you would like to try these on your own, go ahead. This is a fairly new way of looking at average questions, so if you want to just follow along with me, that's fine. Melinda's test average after 6 tests was 73. Her score on the 7th test was 87. If all tests were weighted equally, which of the following is closest to her test average after 7 tests? So we need the average after 7 tests. Fine. So notice right away in this first phrase, I can see that I have a number of things and an average. Well, that tells me that I have an opportunity to use ant. Anytime I see a question giving me an average and a number of things, I know I probably want to use ant. So I'm going to go ahead like I did before and write down a times n equals t. I'm going to just start substituting now. I've got this 73, which is an average. I've got a number of things of 6 in that first phrase. I'm going to go in my calculator and I'm going to do 73 times 6. 73 times 6, and I'm going to get 438. I'm going to pause and I'm going to ask myself, what does that 438 mean? Yes, it's a total, but it must also be her total accumulated points on the 6 tests. In order to have gotten an average over those 6 tests of 73, she had to get 438 points. And in case anybody is still a little bit tentative on the whole ant issue. Remember that in order to produce that average of 73 would have to equal some total over a number of tests. Well, this total up here would have to be 438. 438 divided by 6 would give us that 73. Again, all we're doing is rearranging this basic formula to get this, simply because it makes things a little bit more efficient and a little bit simpler. Now, moving on to the next phrase, her score on the 7th test was 87. Well, remember, this is an actual test score. This is an actual number of points. It's not an average. So what I can do is I can actually add that 87 to her point total after the first 6 tests, and what I get is this is going to be 525. I'm going to check that in my calculator just to make sure. For 38 plus 87, that's 88, not 87. That's going to be 525. Yes. So now my new total is 525. Well, remember, I have a number of tests here. I have 7 tests. So I actually can just use the ant formula again, except that now my unknown is the average. It's what they're asking me. So I'm just going to rewrite the ant formula as a times 7 equals 525. I'm going to divide by 7 to isolate my a, and I'm going to get that a equals 525 divided by 7, which is 75. So my average over the 7 tests should be 75. Let's make sure that's what they were asking. Average over 7 tests, it is, and my answer is D. So that's a fairly straightforward example of how to use ant. Now, number 51, slightly more challenging possibly, but very similar still to the previous question. In a class of 6 students, the average arithmetic mean score of the 5 students who took the final exam on Tuesday is 82 points. The 6th student takes the final and increases the average score for the entire class to 86. How many points did the 6th student score? So points for the 6th student. Points, 6th student. Now, notice in the previous question, we were given one average and a number of things, and then an actual point total. In this question, the big difference, and what makes this question slightly maybe more challenging, is the fact that they've actually given us an average and a number of things 2 times. But as long as we use ant effectively, this question should not be much more difficult in practice. So first phrase here, we're going to focus on this. This is an average right here. They say the average is 82 points. So there's an average, and the number of students that corresponds to that average is that 5. So our average A is 82, and our number of things is 5. That's what I can extract from the first phrase, and I'm just going to go ahead and multiply those 2 things out. 82 times 5 should give me 410, I believe. So that's going to be 410. So again, we're going to pause and just make sure we understand what that 410 is. That 410 is the total points amassed by the first 5 students who took the exam on Tuesday. They got 410 total points. Now, the next phrase says when we add a 6th student in to this group of 5, that 6th student increases the average for the whole class of 6 to 86 points. So I'm going to do exactly the same thing. I'm not even going to think about it. It's completely robotic, completely automatic. I have a new average. I have a new number of things. I'm going to have a new total points. It is going to come out to be 516. I am going to verify 86 times 6 equals 516. Yes, it is. So again, focusing on these 2 numbers, remember what we said the 410 was. It was the total points amassed by 5 students. And then when we factored in the 6th student, we go to 516. Well, if the only difference between this 410 and this 516 is that 6th student, then indeed that 6th student's score, that's a lot of S's, must be the difference between these 2 numbers. So I am subtracting 410 from the 516, 516 minus 410, and I'm going to get 106. There's a difference of 106 points, and the only thing that changed was we added in the 6th student's score. So this 106 had to be the 6th student's score. Now, some students will sit here wondering how you can get a 106 on a test. Well, remember, these are not percentages. These are points. So, the test could have been out of 7 million points or 100 points, and he could have gotten extra credit. Don't sit here worrying why the sixth student somehow scored over 100 points. You did the math correctly. Just trust the math. So again, these questions, this was the number 51. It was meant to be difficult. They tend to be very, very simple using the ANT process. Now, medians. Some students are perfectly fine with medians. They know all the definitions and all the calculations, and that's great. I am going to run through these, obviously, for those of you who are a little bit shaky or need some review. So let's start with a definition. The definition of a median is, a lot of students simply say that it is the middle number. And that leaves out a very, very important point, because if you are under the impression that the median is the middle number in a set and that's all you remember, you are going to come away from a set like 2, 1, 3 thinking that 1 is the median, when in actuality it is not, because the data points need to be put into numeric order, either ascending or descending, before you find the median. The median of this set actually would be 2. So the definition that you should write down here is middle number in an ordered set. An ordered set. Middle number in an ordered set. That is key. You're going to make a careless mistake if you do not remember that. Now, again, order matters. So if the ACT does give you a list that is not in numeric order, you need to put it in numeric order. And I suggest when you do so that you use this crossing off method. In other words, if you've got a set like in example 1, you would list the 1, cross it off of the original list. List a 2, cross it off. List another 2, cross it off. List the 3, cross it off. List the 5, cross it off. List the 7, cross it off, and list the 9, cross it off. I'm doing my cross offs in the opposite order, but that's okay. The way that way will make sure that you don't skip or repeat any numbers. And then, of course, to find the median, some students like to do the end-to-end cross-off method. So 1 and 1, another 1 and another 1, another 1 and another 1, and we are left with the number in the middle, which is 3. That would be our median. Sets with an even number of members or elements. So if you have a set, as we do in example 2, that has 6 numbers, there's not going to be a middle number. So let's relist these. We'll list the 1, we'll cross it off. We'll list the 2, we'll cross it off. We'll list the 3, we'll cross it off. We'll list the 5, we'll cross it off. We'll list the 8 and the 9, and we'll cross those guys off too. So now when we do that end-to-end cross-off method, watch what happens. 1 and 1, 1 and 1. If we cross these two guys off, we're going to have no set left. We'll have no numbers from which to choose the median. So what we actually do here, some of you might already know this, is you average the 2 guys in the middle, or 2 girls. I don't know, maybe these are girls, just want to be gender neutral. You average the 2 numbers in the middle, so you would do 3 plus 5 over 2, your sum or total divided by the number of numbers. 3 plus 5 over 2 is 8 over 2, which equals 4. So the median there would be 4. So in sets with an even number of members, the median is the average of the middle 2 numbers. Average of the middle 2 numbers. Now, in terms of modes on the next page, page 45, you really don't need to worry too much about modes. They very rarely show up, and if they do, most likely just knowing this definition will be enough for you. The mode is the most common or most frequent number in a set. Okay, so if you had 2, 2, 3, 4, 5, the 2 would be the mode. Now, there are some other aspects of mode that can be tested in a statistics course or In a more complex situation, like if you added another 5, what would the mode be? You do not need to worry about that for the purposes of the SAT. The ACT, my fault. The ACT will not test you on anything more complex than just knowing it's the most frequent number. So don't worry too much about mode. Now, stem and leaf plots. This concept has shown up on some old ACTs. It's not very common. Some of you may remember stem and leaf plots, some of you may not. I'm going to go over them here so that you know what you are looking at and don't have to skip these questions, because when they do show up, they are generally very simple as long as you know what you are looking at. So a stem and leaf plot will always involve a 2-column T-chart. So you'll have a column on the left which is labeled stem and a column on the right which is labeled leaf. And what you need to understand is that the numbers on the left are tens digits and the numbers on the right are ones or units digit. So if I had something like this, that 2 is a tens digit, so I'm talking about something in the 20s. And then a thing on the right would be a ones digit. So if I see a 2 and a 3, that's the number 23. Now, you may see multiple numbers in the leaf column. For instance, you might see a 3 and then perhaps a 4 and then perhaps a 7. And what that means is you actually have 3 different data points here. You have the 2 and the 3, so that would be the 23, tens digit, units digit, and then you will have a 2 and a 4, tens digit, units digit, so that will be a 24. And then you will have the 2 and the 7, sorry, these are 2-digit numbers, so 23, 24, and then you have the 2 and the 7, which when you combine a tens digit of 2 and a units digit of 7, you get the number 27. So if you see multiple numbers in the leaf column, they each need to be paired with the 2 tens digit in the stem column. Now, keep in mind, we are not talking about multiplication here. This is not 2 times 3 or 2 times 4 or 2 times 7. We're talking about a 2-digit number where the tens digit is a 2, the ones or units digit is a 3, another 2-digit number where the tens digit is a 2 and the ones digit is a 4, and so on and so forth. So if you were to see a stem and leaf plot like this, you would need to know that there are 1, 2, 3, 4, 5, 6, 7 data points represented here, and they would be a 0 and an 8, a 0 and a 9, which are just the numbers 8 and 9. You obviously don't need to write the zeros. And then the number 12, and then the number 21, 24, 24, and 28. So that is what stem and leaf plots are all about. Again, hopefully not too challenging for most students. Standard deviation, again, another very rarely seen concept on the ACT. If standard deviation does show up, you are not, in all likelihood, going to need to calculate a standard deviation. Your calculator can actually calculate standard deviations using your stat menu. I'm not going to go through how to do that right now, because for the purposes of the ACT, you generally will not have to calculate standard deviation. There's plenty of resources and videos online that will show you how to calculate the standard deviation using your calculator, but again, I'm not going to do that here. It's not necessary. What you need to know for the ACT is simply what standard deviation is. And sort of what it means or what it tells you. So the simple definition, or the simple way to think about standard deviation, is right here. Standard deviation tells us how spread out the numbers in a set are when it comes to the mean. So if numbers are highly clustered around the mean, you're going to have a small standard deviation. Think about what the word deviation means. We're talking about how much we deviate from the mean or the average. And if the numbers are very spread out, we deviate a lot from the average, and therefore we would have a high standard deviation. So if you consider 2 classes, Class A and Class B, both of these classes took a test. Let's say there's 5 students in each class. The average for each class, the mean, was 85.6. But if you look at Class A, you will see that these people scored very close to the mean, whereas in Class B, they all scored very close to the mean. The mean was 85.6, so this person was only, 1.5 points, 1.5 points, 0.6 points, little more than 1.5 points for these two people, but you get the idea. 87 is 1.4 points, 88 is 2.4 points. So all of these people were very close to the mean, whereas in Class B, these people were all over the place. This person's about 15 points below, this person's about 13 points below, this person is over 20 points above. So these people were way spread out. Well, the standard deviation for Class A, and by the way, this symbol, this symbol, some people might take issue with that symbol because I believe that symbol stands for population standard deviation. But again, for the purposes of the ACT, you don't really need to understand the difference between population standard deviation and regular old standard deviation from a sample set. But either way, the standard deviation of Class A is going to be much smaller than the standard deviation of Class B. And indeed, Class A is somewhere around 1.3 or 4, and Class B is somewhere around 17. So you can see the large difference in standard deviation between these two classes, and it makes sense because, again, Class B is very spread out. The data points are very far away from the mean, whereas these are all clustered around the mean in Class A. Now, you might see a standard deviation question that includes or talks about a distribution curve. These have shown up, although very rarely. So I'm going to relate what we just did up here to this distribution curve. Now keep in mind, this is a standard distribution curve. Do you need to understand exactly what a standard distribution curve is or when it would result? No. What you need to understand is that if you see a distribution curve, you're going to have to be able to interpret it. So remember, our class average, the mean, this little mu symbol, was 85.6. If we talk about going one standard deviation below that 85.6, and our standard deviation was 1 point, I believe it was 1.8, something like that. Again, not that important that we know exactly what it was, but if our standard deviation is 1.8, so going one standard deviation below the 85.6, so this is one standard deviation below the 85.6. If I do 85.6 minus 66, let me get out of there, 85.6 minus the 1.8, so what that tells me is that one standard deviation below my mean was 83.8, and then one standard deviation above my mean would be the 85.6 plus the 1.8. So 85.6, I'm going to go up here, grab this, and then I'm going to replace that with a plus, and I'm going to hit enter. So that's going to be 87.4. So in this distribution curve, what I am being told is that 34.1 students fell somewhere within one standard deviation below my mean, and another 34.1% fell in one standard deviation above my mean, and altogether in this area 68.2% of students fell within one standard deviation of the mean. So almost 70% of my students were within 1.8 points of this average score. So again, that tells you we were very closely clustered around the score if 70% of students were that close to the score. Two standard deviations above, well, we would just add another 1.8 to the 87.4. So two standard deviations above would be 89.2. So if we were asked a question like, what percentage of students were within two standard deviations of the median above the median, we'd be talking about this entire grouping or this entire area of the distribution curve. So we'd have 34.1% plus 13.6%, which would be 47.7%. So 47.7% of students were within two standard deviations above the mean That's what that would tell us. 45 is a question testing standard deviations. Pause the video if you want to try it on your own. I'm going to go ahead and do it right now. So the marketing students at Fort Link Business Academy took a placement test for an accounting class. The mean of the test scores is 100 and the standard deviation is 15. In order to be accepted into the accounting class, a student must have attained a test score that is at least one standard deviation above the mean. What is the lowest test score a student could attain and still be accepted? So lowest test score to still be accepted. Well, the day of the test, you were not given on this question, you were not given a distribution curve, but I'm going to actually use this distribution curve just so we can see what's going on here. So remember, the mean was 100. The question told us that. It said the standard deviation was 15. So one standard deviation above was 115, one standard deviation below was 85, two standard deviations above was 130, two standard deviations below was 75. So we have these sort of cutoffs. Now, we don't need the percentages from the distribution curve. I'm just laying these out here so we can sort of see what we're dealing with when we deal with the standard deviations. So the question is telling us that they have to have attained a score that is at least one standard deviation above the mean. So here's the mean, this is the mean, and here's one standard deviation to the right of the mean. So the students have to have scored at least 115. If they scored 115 or above, boom, they are accepted into the program, which means our answer is 115. Now, if you got 116, then you either didn't understand what was going on here, or more specifically, you didn't pay attention to the fact that the question said at least one standard deviation above the mean, and at least one standard deviation would be greater than or equal to one standard deviation above the mean. So the answer there is 115. You get a 115, you are accepted into the accounting class. That is it for means, medians, and modes. So again, to recap, yes, you need to know the basic average or mean formula. You also should definitely know ANT. You should know that when you're given an average and a number of things, you just multiply those, you find the total, and that should be the key to solving the question. Median, middle number in an ordered set. If you have an even number of members, take the average of the middle two. Modes, most common or frequent number in a set. Stem and leaf plots, tens digit in the stem column, ones digits in the leaf column. Standard deviation tells us how spread out a set of numbers is relative to the mean, and then distribution curves. If you do see one, you should know the information on this page. That is all for this section.